constraint-based sketching, line equal length. So let's start with 2 lines. I'm going to use the grid and automatically create constraints is on. So despite those 2 lines were associated with the ends of one another, all we have is parallel and we have vertical. We don't have an equal length constraint. One can be dragged a bit longer. So let's delete those. Let's now try a square or a rectangle. In fact, any rectangle excluding a square. 2 vertical, 2 horizontal, and 4 curve end connections. Let's try a square. So a square, you won't be surprised to learn, has 4 sides of all equal length. So by dragging a corner, all 4 sides change length accordingly. So let's have a look at an inclined rectangle and an inclined square. So let's have a look. What have we got? We've got 2 pairs of parallel and 1, 2, 3, 4 end constraints and a perpendicular constraint. And for the square, we have 4 sides equal length, and again 1, 2, 3, 4, and also a perpendicular constraint. Let's have a closer look. If I select the curve, it can be changed. If I double click, I can move everything. Okay, and on the inclined square, if I pull one curve, you notice that it all moves. Now, to get a change in size, you'd have to reach the connection of 2, and then by dragging you can change the size. As I say, by any selection, the whole square moves due to the constraints placed upon it. If you no longer wanted it to behave like a square, you can select a line and delete a constraint, for instance, equal size. And now any side can be drag-pulled into a rectangle. Another way to change a size of a square would be to put a dimension on one of the links. So just by double-clicking, entering a new size, this changes the square size. Alternatively to that as well, you could place a dimension across a corner. And let's change this to 25. And again, that changes the square size across this diagonal. Let me delete these now. And let's look at another arc and some lines. So I'll draw these with constraints automatically on as tangential. Okay, let me just pin this position. So, okay, now equal length again, equal length. I want this line to be as long as this line. That's fine. I can now move this. And the other one changes length with it. If I now take this and with automatic constraints on again, attach it to the x-axis. This one's now changed, meaning that I can't anymore change the length. It will only change because the other one is free to move along the x-axis. But if I at any time wish to prevent that from happening, like for instance I've now applied a fix to that point, now I can't change that length, and all I can do, in fact what's happened, let me now put a diameter on there. Now for instance I can only drag that around and its length is fixed because it's constrained to that line, the x-axis. Let me delete that fix. Let me delete that constraint. Now by moving this, it moves the other one. 10. Angle. 90. And let's now make that perpendicular to here. Perpendicular constraint. However, I can still move those. So if I look at this line, this end of the line, you can see it's a light blue in color, which means it's not fully constrained. So I can drag it, and I can drag it to a grid position with my grid snaps on, and the other one accordingly changes to the same length. To set an exact length, if I put a dimension on here, in fact, okay, so that's going to be exact, but it could actually be anywhere from that point. So let's say that side would also give me a fully constrained line. And now if I change that to, let's say 20, but if I now measure between here and this point, it will also be 20. So constraints can be added quite quickly once you become familiar with them, and you can use their functions and their abilities to help in the shape of the sketch as the design progresses.